you're going to have to basically have, versions of the API. You can say version one is stable, version one's general availability. We've got some new features that you might want, but we can't promise they're not going to change in any way. So though, so that those are in version two right now, but version two is in alpha or beta. It's not general availability.
Right.
Um, and anyway, the result of Bezos writing that memo, I think we all know, is basically, AWS has had the commanding market share in public cloud for a very long time. They still are retaining it. Like their next two in the US, their next two competitors are Azure and Google Cloud, and those two have less market share in total than AWS has, even today. Um, there are two more, I got kind of two more chunks of quick slides that kind of talk about where Kubernetes comes from. So the next is something called the microservice architecture.
Okay.
And it basically comes down to like, if you've ever heard of the book, Fred Brooks's book a long time ago called Mythical Man Month, or any of the software engineering books that have come out of like Microsoft Press, they basically said, like, listen, suppose you have five developers working on something, you know, and you just got a big cash infusion from venture capital. Now you can get 50 developers. You're like, wow, we're going to develop 10 times as fast. And what you find really quickly is, no, you can't. Like just doubling the number of developers doesn't double your speed,
Right.
because there's a lot more communication that has to happen between everybody. There are a lot more meetings.
Yep.
And in the, a lot of bunch of those meetings, and I know, Brian, you've got, like, this is some of your professional experience, right? In a lot of those meetings, you'll hear someone say, hey, hey, Joe, or hey, Robin, how's that going? And Robin will say, um, uh, my last milestone's done, but at this point now I'm blocked waiting on Joe. And Joe kind of looks sheepish or whatever, but it's not that Joe's a slacker. It's that, like, different there are a lot of dependencies that will happen in a program's development. And so you'll have this, like, I'm blocked waiting for thing that happens in meetings a whole bunch the larger the team gets. So there's this architecture that's come along called microservices. And it has a bunch of advantages, but one of the big ones is speed of development. You say, hey,
Right.
I've got this program, like this e-commerce program. I kind of made a slide here, and instead of having that be one monolithic program, I'm gonna break it out into 10 smaller programs. All 10 of those programs will basically have an API on them. It'll be a versioned and documented API. And now, instead of having 50 developers on one program, I have 10 different programs under development, each with just five developers. This is going to be, like, the communications overhead much
Mm-hmm.
smaller, the dependency overhead much smaller, because now you're getting that thing that everybody's always wished. And, like, no matter what you've worked on, you've just been like, man, why can't we just work on our part? Why do we have to know about all the other parts and be quite so intertwined? You get to be like, no, I make a black box. My black box is a recommendation service. It's this thing that, like, you consult, you say, hey, the customers bought these things so far. What would you recommend to them? And the recommendation service might have a dependency. It might go talk to a product catalog and look and see, what kinds of things it could offer. But at the end of the day, you get this one piece, small number of developers can work on it. And also, the recommendation service needs a lot more resources than other things. It can scale up without the whole rest of the program, the whole rest of the app having to scale up. So this microservice architecture has been really, really useful for, like, speeding development. But it means now all the different parts of the program are going to have to find each other. And that's one of the places we're going to talk about, like, where kind of Kubernetes will come in.
Okay.
So one more history slide. So Kubernetes is in many ways based on Google's Borg project, and Google's the Borg um, is what runs Google's data centers. So there's a GlueCon presentation from 2014 by Joe Beda, one of the creators of Kubernetes, one of the original founders, and he shared a few things. One of the things he shared, big quote, was Google launches 2 billion containers per week. That was back in 2014. Don't know what the number is now. It's usually higher, right? But that means 3,300 times a second, Google's launching a container.
Right.
Um, wait, why are they launching containers? Well, containers going to be any program that somebody at Google wants to run. That might be somebody saying like, um, well, I've written a program that I want to run once and do some machine learning, stuff. Or it
Mm-hmm.
might be that like you just logged into Gmail and, you've gone and hit, you're going to hit reload on your inbox. And so now there's an incoming request that wants to read Brian Breaks' inbox. Um, whichever, any of those kinds of things will launch one container. So you're like, okay, well, who cares? You got to launch a container on some system. Just launch it. Okay, well, this is Google. They do things at pretty big scale. So they have a lot of servers. How many servers? 2016, it was 2.5 million. Um,
Wow.
so that means 3,300 times a second, something that's going to be the Borg at Google has to choose which of the 2.5 million servers to run that program on. Has to take into account like which servers have how much RAM available, how much CPU available, and figure out the right best place to put it. This problem is called bin packing. Um, so it's kind of like the whole loading a dishwasher thing, except you have 2.5 million dishwashers, and you put addition one of the dishwashers 3,300 times a second. So it's kind of one part of like why Google has to automate their data centers to this level. But another part is just think about hardware failures. So, if each one of the machines in their data center had a boot drive, had a hard drive, and if one of those hard drives failing would mean that the server was going to fail,
Right.
um, well, they probably deal with a lot of server failures. Hard drives, annualized failure rate of about 2%.
Mm-hmm.
So if there's one drive in every server, you have 2.5 million servers. That means every 9 minutes they're suffering a hard drive failure.
Goodness.
Um, so yeah, that means you've got to be able to handle like a whole bunch of things. You've got to be able to handle machines failing. You've got to be able to handle workloads failing. And if you're going to get all those nines, 99.9, however many nines you go for, um, it's a little bit of a challenge. So this is what they use the Borg for, and Kubernetes is basically trying to create something like the Borg. Um, and it's a big open source project that they released a while back. So Kubernetes, so this is kind of like gets into and I think I'll stop here after this slide, but just Kubernetes gets into um, what would you need to manage either a very very large data center or just to be able to say, wait, sometimes we're making use, I'm just like going to pick random numbers out of the thin air, like sometimes we're using 200 computers and other
Right.
times we're using three, like just kind of imagining the company that's not doing as much in the middle of the night or whatever. um like how do we make it so that we're not like, if we're able to make those computers cloud virtual machines, like how do we make it so that we're not spending quite as much on our cloud bill all the time? Um, but on the flip side, when things do get really really busy, like we can really really efficiently get a whole bunch of resources and use them. And so Kubernetes basically has some of the this kind of, I put up on a slide a feature list, and that feature list kind of shows you what you're building. At the end of the day, the idea of Kubernetes is to kind of give you the equivalent of like a software-defined data center, not just a software-defined network, but a
Right.
software-defined data center, by way of saying we're going to put everything in a container. We'll use containers instead of virtual machines for our work. And you end up getting, because you're using containers instead of VMs, you're getting something that um, that can kind of scale very
Mm-hmm.
fast. It can handle failure very very fast, because starting up a virtual machine, like that takes some number of seconds, not a full minute to boot, right? But starting
Right.
up a container, like fractions of a second.
Wow.
So yeah. So Kubernetes, what does it do? One thing we talked about bin packing, just figuring out like, you say, listen, I've got a program that I'd like to run on one of the machines. I've made a container image, like a Docker image. I'm going to say Docker. There are a whole bunch of container runtimes, but I'll just say Docker because it makes it easier to follow. So I've got a container image, maybe it's up on Docker Hub. And what I'd like is I'd like to say, hey, Kubernetes, can you run, I don't know, say 2 or 3 copies of this, just so that if one of them crashes, if one of the machines that's running those things crashes, or if the program crashes, then I still have things going. Like, so could you find 2 or 3 systems to put this on and put it on there? And then keep things self-healing. If you put if you made 3 containers running my image and one of them crashes, just restart it. Like, if it crashed because that machine crashed, then do me a favor and automatically find another machine to put it on. And so Kubernetes has this kind of cool feature. It's declarative instead of imperative. So you declare what you want the state of the data center to be. You basically say, in my software-defined data center, I'd like there to be 3 copies of this container image running at all times. Like, you figure out where to put them. If anything
Right.
goes wrong, just get things back to there being 3 copies. So that's that kind of self-healing, and it's
Yeah.
neat. You can also be like, listen, this app may get popular, so I'm only asking you to run 3 right now, but if things get really, really, I was going to say insane, if things get really popular, then you could run up to 50. So
Right.
I'd like there to be between 3 and 50 copies, depending on the incoming load. It's like Kubernetes is like, that's just fine. I can handle that. So that's horizontal scaling. Um, you could also say, wait, we also get kind of load balancing, and where you're like, I don't want to, in Kubernetes, you don't have to know the name of any of the containers. They're actually called pods. You don't have to know the name of any of the containers that are running or where they're running. You just basically use these kind of things called labels, and you create a load balancer, a software-based load balancer that says, okay, any traffic coming in should be resent out to any containers, to any pods that are labeled with the right set of labels. Um, it's kind of cool. And then
Yeah.
Kubernetes can handle all the secrets, the passwords, the TLS private keys, all those kinds of things that you push into a container. It can also handle configuration. So one of your goals is the container image that you put up on Docker Hub should never have passwords in it, but ideally so that it can be used kind of more widely, and can be easily used between your staging, your production, your development environments without having to change the container image itself. You
Mm-hmm.
say, I'll start the container image and then I will push in the configuration. Kubernetes will push in the configuration that I set separately, so I'm not pushing my configuration up to Docker Hub or whatever my image repo is.
Yeah.
Um,
So, so,
yeah.
so anybody who's watching on stream, please feel free to ask questions if because that's what we're here for. But I have a question. So Kubernetes does, a lot of great work. If you have few resources, this can actually help maximize those resources. It sounds like. Is there anything that Kubernetes does not do well?
Oh wow. Um,
I mean,
uh,
there are Windows Docker images I've heard now. So I mean, Windows will run in a Docker image. I don't know about Kubernetes, but is there anything that Kubernetes is not good for? Like maybe it's I'm just thinking on the other side here. It's like, what would you be like? Well, okay, you can't use Kubernetes for this or whatever. Or is there actually nothing that you cannot use this for?
so first, I've met a whole lot of the people working on Kubernetes, and so I'm immediately like thinking like, I'm going to say it won't do such and such. Like it's not good for such and such. I'm thinking like, man, they might be mad. Um,
Oh, don't worry.
um,
They're not watching. They're not watching. It's fine. It's
oh yeah, good point. Good point. Right, right.
fine.
Yeah, yeah. There's only 2 viewers. It's you and me, right?
That's right. Just you and me.
Yeah, I'm trying to think about that for a second. Because whenever I think of examples, I start thinking of like that there are people working on developing capability, those capabilities. So it's
Right.
yeah, I'm just trying to think for a second.
Because I mean,
Um,
if you're coming up blank on something, then somebody whose management's like, well, you've got an IT person or a security person is like, hey, we should probably think about using Kubernetes as a cost saving feature. And, the management will be, saying like, well, we do all this, we're a special case and, we can't use Kubernetes. And you'd be like, yes, we can. Or, oh yeah, you're absolutely right. We can't use it for that. I mean, I was just thinking in terms of that kind of scenario where somebody might say, oh, well, we do this, and this. We can't use Kubernetes. And you'd be like, oh, yes, you can, or whatever. So,
Yeah, the hard part about that question is that at the end of the day, um, I'm much more an infosec person
mm,
than a building, than a building things at scale person.
right.
Um, and so, there I haven't had I haven't had the same kind of strong, um, I haven't had the same kind of strong I haven't run into the problems that it doesn't do as well on. I've got a friend who I did who I was on a panel with a few years back toward the beginning of the pandemic, and Marlo Weston, and she was specifically put this panel together with a few other really bright people to talk about doing Kubernetes in high performance computing environments, and to talk about like in which places was whatever resistance there was in HPC, um, justified with Kubernetes, and which places was it really, was really not. Or I think there wasn't so much
Hmm.
the resistance to using Kubernetes and HPC, but rather using some security functionality or features, and a lot of it turned out to be bull. But
Mm,
I've really enjoyed talking with her and other people in HPC um, about kind of about like what they're having to do, what they're going to do in engineering to make it so that they can get some of what they're seeking in those environments and really speed optimize things. So what I can
okay.
say is I I don't know things it's not, I can't think of anything that it's not good for. And the cool thing is that if there are things that it's not good for, very often you've got really bright people who are moving the needle on that. And Kubernetes is in such active development, and it's got so
Right.
much enthusiasm behind it that they're moving the needle pretty fast. So
Okay. All right.
um, yeah.
We do have a question from Bloodbound here. It says, I have a question. You compared virtual machines versus containers. VMs still need hardware to even exist in terms of origin. So, what makes containers special? I think containers do less virtualization, but I don't see how that's better.
Sure. I'm gonna stop my screen share for a second.
Okay.
Um, um, so so if is this something where I can I actually haven't been on your podcast since the Twitch switch, I think.
Yes.
Is there a
Oh, I love that. The Twitch switch. Very
the Twitch
nice.
switch? Yeah.
Okay.
So I wonder, can I join the Twitch and see the questions in real time that way too, or is it
Yes, you can. You can
okay?
go to twitch.tv/breaksec and yeah, check that out. I think we're nearly real time. So twitch.tv breaksec.
Okay, cool.
And you can, yeah, there you go.
I'm logging in. So I think I'm watching an ad at the moment, but I think if my
Oh, I
volume
need to
doesn't
turn that
exit.
off. We don't, yeah, I don't like the ads. I got to figure out how to turn that off. You can also join our, Discord. I know you and I are kind of our friends on Discord, but we do have a Discord as well. So
Oh, I need
Discord
to do that.
GG breaksec. We have a vanity plate now, so I'll send that to you on Twitter as well. But yeah,
Man, I am dumb when I try to multitask. I'm like walking through my whole um, 2FA thing looking for Twitch.
mm.
Oh no, it says you can request the code via SMS. Come on. Darn it, I'm gonna have to set up a token for that. And now I've just told the entire internet that I am using SMS for one of my 2FAs. That's not good.
Oh yeah, Kimisek is actually correct. Another reason for our subscribers would be no ads. We don't get ads if that's set up. I think it's a default of like a 30-second ad. So, but thankfully it's not like NordVPN. I think it's probably like Progressive or something like that. I have an issue with NordVPN. So, um, you know, in terms of what it promises versus what it delivers. So as long as it's not a NordVPN commercial, I think Progressive isn't completely awful. But um,
Ah, I need to be a follower in order to chat, so I can follow. I can't believe I wasn't following. That's dumb.
Hey, look,
Okay.
we have new followers. His name is JBLE or something. I don't JBL. That's
Hey.
what it is. There you go. Yeah, the handles on it. Yours is actually quite nice, JBL. So Chemist Security. Thank you again for subscribing for up to 3 months. So that's very much appreciated. Um,
Awesome.
so let
Oh, I
me
really.
here. I think I can quote his message. There we go. Uh, Doink. There we go. You should be able to see it now.
Okay, sweet. Thanks.
Or
Okay,
not.
there we go. Yeah. So VM still in the hardware to exist, even in terms of origin, so it makes something special. Okay. So thanks. I just sometimes it just really helps to read.
No, it's all
Um,
good.
so the and I need to get the video away because the lag is killing me here.
Yeah, there's about a 10
So
second lag. Yeah.
yeah. So cool. So containers versus VMs, or containers are running in a VM anyway, right? So first, if you're Google or AWS, or Amazon, you probably, I'm pretty sure you're running your containers actually on bare metal hardware, which is to say, you're running, Linux on, you're running Linux on bare metal and containers inside that. But most of us are running containers inside VMs. So, when you say like, yeah, so wait, how is there any advantage? You just said you're going to add yet another layer of organizational thingy.
Hmm.
Um, and yeah, it's a fair question. The idea of the containers, um, it's kind of like, if I was going to, man, I probably have slides on this, but the idea of the containers is like this. Um, Man, I just want to go into the history of it for a second. So the history of containers. So we've heard of like platform as a service companies, that kind of like Heroku and so on, where you're like, I have my program and I want to just upload my program to run on somebody's platform. And the platform's going to allow my program to, like, my program's listed on port 80. The platform's going to kind of give me an IP address, and it'll give me hit some IP address or hit some name out on the internet, and it will come and it will land on your program port 80, right? So um, imagine like when those platform as a service companies were first starting up, they're like, okay, so like imagine you're talking to their CISO, or their infosec folks, and their infosec person says, okay, so what you're telling me, manager, about your business model, about the proposed business model is, we've got a whole bunch of these, VMs or whatever that we have from cloud providers. Maybe we have, whatever we have machines, whether they're virtual machines or hardware machines. But you want to run like you want to run like anybody on the internet's going to be able to give you a program, and you want to run it on a machine. You're like, yeah. So you're going to give them all a VM, right? You're going to give, you're going to give, like, Brian wants to run his little Python program on here. You're going to give him a VM. Jay wants to run his, Uber Elite Visual Basic program on here. You're going to give him a VM. Like, we've got these kind of beefy servers, but that means, like, per server, we're probably going to get about, what, 16 customers on there. The
Right.
manager's like, dude, these programs are small. Like these programs are, like Brian's Python program, it needs, like, sure, it needs a half a gig of RAM, and Jay's Visual Basic program needs about, I don't know, 512K, because what more would you need than 512K? Um, and we should be able to fit a lot more of them on there. And you're like,
Right.
yeah, but the way we do this, we give them all VMs, and I can't really put that many VMs on a piece of hardware. Um, it's like, well, so as the technology person or as the non-security person for a second, you're like, what if I could take an operating system? What if I could run them all on, all on the same computer without having anywhere near the same kind of security issue? Um, be like, well, what do you mean? Or let's leave the security alone for a second. What if I could put them all on the same computer and everybody could think they were getting their own kind of VM? They could all listen on port 80 if they wanted to, but they wouldn't collide. You'd be like, the hell are you saying, man? You can't do that. Like only one thing can listen on port 80. What are you going to do? Give every single program its own network interface, its own IP address? We're like, yeah, let's do that. That'd be good. Well, okay, but they're both going to try to write to the same directory in the file system. You'd have to give them every single one of them their own file system. Yeah, let's do that. Oh, what? You're going to mount a separate disk for all of them? No, 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 no. Don't worry. We can kind of like mount a loopback file system onto a directory and then like kind of cheroot them into that directory and be like, well, I guess that would work. The cheroot's a little funky, but yeah. I mean, well, wait, what about shared memory? Like they're going to interfere with each other's shared memory, or at least if we're going to give them both root, oh, well, what if we could like, what? I think now what we've got going on is a Linux kernel project. I think what we should do is go like I got some friends who like to work on Linux kernel code. Why don't we modify the Linux kernel? And we'll
Hmm.
add this thing to the Linux kernel and we'll call it a namespace. It's a weird idea, but like you could also call it a view. And what we'll do is we'll say Brian's program will get view number, one of the system. And in Brian's program's view, there's one network card. It's going to be whatever Brian's network card is. And the IP address for the network view will be, we'll have the IP address being 10.1.1.1. And then J's will have view two of the network, part of the system. It'll have 10.1.1.2. And for shared memory, we'll modify Linux kernels so that Brian's program will see kind of shared memory resources will be just the ones for shared memory view one, and Jay will get shared memory view two. Okay, cool. We'll do that with the mount. We can do it so like Brian's program will get the mount view of the system, mount view one. And mount view one, maybe we're just mounting some tarball or whatever. But hell, mount view one could also mount an NFS mount in and or whatever. And Jay's little Visual Basic program, I don't know, he can have mount view two, and he probably won't need to mount anything funky in. But that means like Brian's program, I mean, Brian's program was kind of written against, Ubuntu 2204, and Jay's program was written against Fedora 3. And we can facilitate that. They'll just each have their own file system that'll be like that. And so these views are actually called namespaces, and they were created specifically for the use case I'm talking about right now. And platform as a service, um, um, provider basic, I think OpenVZ was the big one to start, but basically said we're going to create these kernel namespaces, and these kernel namespaces will give different programs different views of the operating system. So this wasn't so much a security feature, although it became kind of one. It was more like, how do I let Jay and Brian both be on the same piece of hardware and not have to give them each virtual machines? Because now instead of on that piece of hardware where I could have put 16 virtual machines, I can put, more like 100 containers. So
Right.
first, it's just a really efficient way, Bloodbound. It's like a more efficient way to chop up a system. Um, but the next part is that I can say, wait, like I don't have to, Jay doesn't have to give me an entire, Fedora 3 operating system. He just needs to give me, worth of files. He gives me his program, and I'm kind of moving out of the platform as a service thing now into kind of more of the Docker Kubernetes version. But it's like If Jay wants to run his program within Docker, he's going to provide a file system. And that file system might be as big and fat as Ubuntu 2204, but it might be super, super tiny, like, Google's distro list, where there are like, maybe there are six, maybe there are six total files in there,
Right.
in the entire, file system. And the trick is that Brian and Jay are both going to share the same Linux kernel, but the file system that they see will be different. One for Brian, one for Jay. And the
Right.
and there's crazy things about what you do when you go to this model. So the thing that most of us know, most of us run into first with Docker is like, wow, this is a really great way for Brian to be able to write a program and share it with other people, and they won't have to figure out what libraries to install and fight all the dependencies. They just all they got to do is have a copy of Docker or another container runtime, and go grab Brian's image. They pull down Brian's image, they're ready to go. So that's kind of the first thing you get out of it. You also get that efficiency part out of it that I was describing. Um, but if you start operating at scale, if you start operating with lots of computers, or needing to have things change really fast, because the container images can get really small. You ever had the whole thing where someone's like, hey, yeah, download my VM and then run my VM? You're like, okay, I'll set the VM to download, and 5 to 60 minutes later, it'll be done downloading. And then I'll copy it around to whatever systems I want to run it on. And then I'll start it. And that takes a while because the VM is, because that,
Right.
that VM's big. It's 500 megs, what I don't know, 500 megs is pretty small, but its size is measured in the gigabytes. But if you write a program and you create a container image that's the absolute smallest you can get, there's one cool thing is if you've ever made a Docker container, there's a tool out there called Docker Slim, which will run your container, figure out what files are actually being used, and create a slimmer version of your container image that's as tiny as humanly possible, that has the fewest files that you're going to use. If you can
Nice.
make that container image like a few megabytes. Now that's insanely small, but if you can make the container image a few megabytes, well, now if you're running in your data center on one system and now you want to run it on 10 more, well, cool. They can all pull, like think about cloud providers with 40 gig E, with their physical systems are running 40 gigabit Ethernet, maybe two 40 gig cards lagged, maybe even couple hundred gigabit cards lagged, although that sounds unlikely. But they're running very, very fast networking, and now you're talking really, really small files, and those files can be cached. Wow. You start being able to spin up workloads, spin up, like, have that horizontal scalability, being able to spin up, go from 3 copies of something running in a data center to 50 copies and back down really, really, really easily. You end up being able to have that self-healing where it's like, oh, a program, like one of the containers crashed. I need to start another one in another system. That's okay. Boot time in a container is fractions of a second. Um, and if you start looking into the mechanics of how serverless or function as a service works, you start like really, really quickly, you start realizing like, oh, wait, this can get like, you can get some real power, you get some real power and some real flexibility out of this. And
Right.
um, there's one more thing that makes this, I'm sorry, I get really excited about this, but there's one more thing that makes that really super efficient. And that is that when if you look at Docker in particular, you have this idea of a Docker file, which is like a make file. And what it does is it says instead of you pulling down a container image and that image just being one blob, you pull down a container image instead is like multiple small file systems,
Hmm.
where you've got kind of the first one, and then if somebody, sorry, this is easiest by example. If Brian were to push up a container image up to Docker Hub, and I pull it down, and like I start running Brian's program. Maybe the first time I pulled down a container image, it takes 30 seconds because it was fairly big. But then Brian's like, oh, hey, wait, I've made a change to the container image. I've modified the one program that's running in there. I've modified one of the data files. So if his change, say, is like all of 6 bytes, when he pushes the new version of container image up to Docker Hub, he doesn't have to push his whole 500 meg container image. He just pushes those 6 bytes up.
Right.
And then when I say I'd like to get the newest version, if I have the old version, I only have to pull down the 6 bytes that he just did. So now I've got this way of saying, okay, first that kind of makes it really fast to develop software. But the other is, if kind of like if I have a bunch of VMs or a data center worth of systems that all have kind of the base, breaksec container image, and and now to run a program in that environment, all I have to do is like basically I create container images that are based on the breaksec image, but just with one program added. Then all that has to move is that one program, and all of this gets really automated. So now it's just fast as heck for
Right.
Brian to start operating, using that container image for Brian to start operating his, serverless or his function as a service. So
Yeah.
that's a very long answer, Bloodbound, but that's kind of where we're going with it.
Yeah, no, it's interesting because a lot of the things you were talking about, especially with the history there, it seems like that those technologies have always kind of been there. I mean, process isolation. You had mainframes before even computers that could do process isolation, and you could take specific processes would have only a certain fraction of the resources on the system being a CPU time or what have you. And then you have then software defined networking came in, and then jails and shroots and stuff like with open. I was using OpenBSD back in 2004, 2005, and having to shroot my lamp configuration. It seems like all of that stuff was already there. It's just it took somebody time to go, well, I can take this jail thing here, and I can take this process isolation here, and I can take SE Linux from here, and I can, you know, create a blob of your resources from the cloud and put this in here, and it just all kind of amalgamated into either Docker, Kubernetes, I think Linux containers, etc. So it's just interesting to see all these technologies kind of meld together into something that is actually better for computing overall in terms of less wasted resources. I mean, how many VMs do people have running in their environments that are sitting at 1-2% or something, and they're some of them are
God, yeah.
dedicating several hundred gigs of drive space that they'll never use, that they could have used for 1,500 other things. So it's just nice
Yeah.
to see better resource utilization, and it's definitely a cost saving measure in many cases. So yeah.
Oh heck yeah.
Yeah.
So it's really neat. It's fun.
Yeah, very cool. Did you want to? You said that there was an example in Busticube that you
Yeah,
wanted
let
to
me
run us
demo
through. That
something.
yeah,
Yeah. So I'm gonna share my screen in a sec. Let me just get this up. So what I'm gonna do is just show you an example of an attack
and I'm gonna
and share
put
screen.
Busticube in the put the link to Busticube in the chat
Thanks.
for everybody to take a look at.
So I love doing demos, and I also love recording them for many reasons, including that makes my typing look a lot smoother. So let's see, playback speed, faster. Cool. So this is a scenario. If you're interested, if you I do if you look on InGuardian's Kubernetes website, you'll find that there's a talk on there. It's a YouTube link for for a Blue Hat conference. And at that Blue Hat conference, I gave the longer version of what we're about to do, and I talked through a lot more. But we're going to just look at a part of it. So what I made for this was kind of um, was a scenario based on a movie called Scott Pilgrim versus the World. And if you have not seen Scott Pilgrim versus the World, um, I'm not going to say turn off Twitch right now, but if you're listening to this as a podcast or whatever, pause, come back to it, go watch the movie first. Not because not because it's a prerequisite, but just because something's wrong in your world. You have to see this movie. Um, um, it's like when somebody says they don't like sushi, and I'm like, oh, there gotta be treatments for that, like you can fix that, right? Um, I am kidding in both cases. I understand that different tastes, different people, and all that. But anyway, Scott Pilgrim versus the World. It's a really, really fun movie. In it, Scott Pilgrim is well, he's our protagonist. The movie, in some ways, is kind of like a comic book world or a video game world. It's live action, but it's like these people are living in a video game.
Okay.
Um, and it's really fun. Scott's one of our protagonists, and he's just begun dating Ramona Flowers. Um, and Ramona tells him very early in the relationship that if they are going to continue dating, then he will have to defeat each of her seven evil exes. And so we have the seven evil exes here on our screen. And what I've done is I've kind of made a Kubernetes cluster that has a scenario on it where you kind of linearly go through challenges, and each of your flags that you get corresponds to defeating one of the evil X's. So this movie is apparently old enough that it like hit its 10th anniversary recently, and I swear it was released yesterday, but that's how it
2010,
is.
yeah.
So I think it's
2010.
on Netflix for free.
Okay.
Um, and it's on at least one streaming resource for free. I've bought it twice now, but it's really really good. And anyway, so here we are. So let's see. So I'm going to start this up, and what I've done is when you're doing attack and defense in Kubernetes, it's not very interesting from outside the cluster. There's not much you can do because a Kubernetes cluster, by default, kind of doesn't have much of an attack surface, and anything that's visible from outside the cluster. It's not like a network where you're like, oh, we forgot that that's available to the internet. It's like, no, no, it's everything visible to the outside. Someone had to decide to make visible to the outside. So for the most part, what you find is a cluster is kind of that, what we used to say, it's like a network with a firewall. It's a, crunchy, crunchy outside shell, nice
That's right.
gooey, chewy inside,
Yep.
nougaty layer. So here we go.
Mm.
So to make a scenario, anytime you see one of these that I make, they always start with, oh gosh, I have to come up with some kind of remote code execution vulnerability so you can get inside the cluster. So here we go. We have this page and it says, hey, which of the evil X's bios would you like to see? So you get a little drop down. You can choose, one of the seven evil X's. There are only six options because two of the evil X's are twins, who are defeated at the same time in the movie. So you pick one and you hit pull X bio, and you get a bio, and you get this bio from the Scott Pilgrim fandom wiki page. And what we can find really quickly is when we go to pull one of them, we get this debug message. It says command failed, curl, HTTP Lucas Lee API bio. So what that means is whenever we're hitting this button, there's a program getting run. So nice little RCE. We need some kind. Um, so what we do here, we're going to fire up Burp Suite. We don't need the paid version of Burp Suite. So there's a nice free version of Burp Suite, and we just do an intercept. We just intercept the traffic going from our web browser to the web server that's running Kubernetes here. And what we find is that if we look at the parameters, there's a parameter called evilx that's set to Lucas Lee. There's a parameter called submit, goes to bio. But if we see that where that Lucas Lee shows up as the parameter and look at the debug message, we realize like, oh wait, the we're having our input pasted straight into a command. And so the developer here was trusting that a drop down menu, which only had six options, that whatever the input was coming from that drop down menu would be only one of the six options. But that's wrong. So we're going to put in a semicolon and an ID and find that now, we got a nice little way from here to run a command. So this isn't Kubernetes specific. This is just a
Nice.
way of us getting to, we just need to be inside the cluster somehow. So put a nice, easy to find vulnerability there. So now what we do is just take that same request and in that evilx Lucas Lee, we put some other command in. So we're gonna, I like to use, Metasploit anytime I'm teaching or doing demos, just because we can all get it easily. And so what I've done is I've created interpreter reverse shell binary, MRS bin, and I'm hosting it on a web server. And so I'm going to tell this program to please hit my web server and pull that binary. And not just pull the binary, but make it executable and run it. And this is just going to get us into our cluster. So I'm hosting that web server and I'm firing up Metasploit console. And I like to really try to make sure every demo is like something you could like go back and pause and, hit pause a lot, but basically follow along. So hit go, we catch a session.
Nice.
And we're in. So now we're in our first container. And this container is in a pod in a Kubernetes cluster. So Kubernetes has the smallest unit of work, smallest unit of compute in a Kubernetes cluster is a pod. A pod can have one or more containers in it. So we're in a container in a pod. This pod seems to have as its, the host name in here is this container, its host name is Matthew Patel Intro. So what we're going to do now is actually go and get a copy of kubectl. So kubectl, some people say kubectl, some people say kubectl, but whatever your pronunciation is, and that's a religious war within the Kubernetes enthusiasts.
Kubectl, okay. I hadn't heard that one. That was
yeah.
Okay.
I don't like that one very much. It sounds a little, I don't know. It sounds because I'm an attacker. Like kubectl sounds icky. Sounds. Yeah. So anyway, we're gonna go and you can I show you the hit the web page that says paste this command to get a copy of kubectl. So we'll download kubectl straight into here. I did put it in /temp to find a writable place to put it, and then I'll mark it executable. And now I've got something that could try to interact with the API server. So inside of Kubernetes, you've got so all of Kubernetes is basically API. There's and it's a well-documented API. You can download the Postman file or they call it Postman file. People call it Postman file. Other people call it a Swagger file. I like to call it an open API file, but you pull down the API file and into Postman or just read it on the website and you can get Kubernetes to do lots of stuff. So another way of doing that though is just use kubectl. And so we're going to download kubectl, and the first thing that happens when we try to use it is it says, hey, I don't know where to find the API server. Now, in this video, we're going to go and figure out where to, its IP address. But before we do that, let's note that we're in a container in a pod. If I type mount and grep for something, I'm going to find that there's a service account token that every container in Kubernetes, unless it's turned off, automatically gets a service account token mounted into it for some service account. And often those service accounts might be overprivileged. The tool called Paratis that a bunch of us in Guardians worked on actually lets you kind of collect these service account tokens. As you collect them, you're able to do more and more. So I can go and grab that service account token, and I can see that there's a CA cert that lets you have TLS connections with the API server. I can go and get the service account token, and that service account token is actually a JSON web token, a JWT that's been signed, signed by the CA Kubernetes in this cluster in particular. I also find there's a namespace, and so this is the default namespace. And so what I'll do is I'll set up a kubectl command, and I'm going to create an alias, and the alias is going to say go and so I've grabbed one of the default IP addresses, but there's actually a DNS entry that gets put in by default that we could be using instead. And then I put in the path, the contents of that token. And once I do, I'm able to start running commands. It's the first command I run. I ran kube control get pods. So pods is what the containers come in. And it's like, okay, gave me a bunch of pods. And each one of these pods basically corresponds to one of the evil X's. So we're in that Matthew Patel intro pod. But then there are some others. And what I'm going to do now is just try uploading a file. Oh, I can't upload. Switch over to temp and try uploading again. I'm going to upload this pod definition file. And man, there's so many things I could show you. But in this video, we're just, if we're allowed to create pods, we can actually do some pretty awful things by default in Kubernetes usually. Um, uh, Not necessarily in this case, but this one says, we get this argument that says, hey, you can't, your user, your service account you've got is not going to be allowed to create that. So we try to create a pod, we're not allowed to. What else can we do? We can try and ask for what secrets are available. Can we get a list of secrets in this namespace? Is our service account allowed to do that? It says, nope, you can't. Darn it. So we'll have to figure out what we can do. So we can use, there's something called auth can I. So you can do kube control auth can I, and then ask it for a list of all the things that you're allowed to do in the namespace. So I'm gonna let's stipulate that I've done that, and I'm gonna try doing, like, if you've ever done a Docker exec, I'm gonna do a kube control exec, which lets me say I want to take some other pod that's running here, and I would like to run programs of my choice in that pod. And says, nope, you're not allowed to do that either. Darn it. Okay. Well, I'll try some other stuff. Oh wait, there's a flag. Okay, if you're in a CTF, you should always go looking for flags, because the flags will often tell you what to do next. So this says, hey, you beat Matthew Patel. We beat him by getting into the pod, by finding that vulnerability. So we get this kind of nice little, screenshot from the movie, and it says, now that you beat Patel, go after Lucas Lee. And crazy thing about this movie is actually that a bunch of the actors in this movie turn out to have been like star in Marvel movies. So this is Captain America,
Right.
Right. So
America's ass. Yeah, that's America's ass.
That's America's ass. And then Marvel, Captain Marvel, it plays one of the antagonists in this movie too.
Okay.
So this says this page queries a microservice. It says this page queries a microservice of Lucas Lee fan requests. So Lucas Lee is that skateboarder Captain America that we just saw. It tells us where to hit. So I'm going to take that URL and curl it, and it says, hey, this API accepts, has endpoints /bio and /grindy thing. So we can hit /bio. That's what the front page was doing. We already know about that, so let's hit that grindy thing. And it says grindy thingy. If you hit this URL in the movie, this character is defeated when we ask him to do a grindy thingy trick. So we're going to go and say, we'll hit grindy thingy, and we get a quote from the movie. But it also said we can put command equals some base64 encoded command. So let's echo ID to base64 and get the characters that would come out of that, and let's paste that into, let's make this request again, and command equals and that. When we do that,
you got root.
We're getting some command running over in this other pod. So cool. So now, since I've told you I've got Metasploit running, I've got an interpreter, that we can pull down. So my command's now going to be, hey, pull down this Metasploit reverse shell binary program from my web server and mark it executable and run it. So let's do that. Now, in a Kubernetes cluster, by default, there's like no network segmentation. Every pod can reach every other pod, whether you intended that or not.
So there's no trust barrier. Everyone trusts themselves inside the pod. Okay.
Yeah. And this is actually partly for, like, this is in some ways I feel like it's in some ways for like kind of backwards compatibility reasons. So Kubernetes project was doing a lot, and they decided that for their for their main for what's called their overlay network, for the network that allows all of the nodes of the cluster to all talk to each other, and for all the pods that are running on all those nodes to talk to each other, you have this overlay network. And that overlay network serves a few purposes. One is that means you could have nodes of your cluster that are on whole different cloud providers and whole different networks and so on. The overlay network's job is to kind of make it so that everything can talk to everything. So Kubernetes was like, we're not going to make the overlay network. Instead, we're going to make an interface and let other software projects or vendors create overlay networks, and then the users can decide which one they're going to get. What that means is, to do that, they said, okay, well, here are the rules to be certified as an overlay network that can work for Kubernetes. Every node is to be able to reach every other node. Every pod is to be able to reach every other pod. There's no security part built into there.
Hmm.
Now, at the beginning, some of the overlay networks could handle some network segmentation, some of them couldn't. So there's this thing called network policies, and I found out the hard way that some of the overlay providers didn't support bidirectional network segmentation. Anyway, interesting. So everything can reach everything. Let's keep going. Let's take that big old command that we've base64 encoded and hit go on it. And now I'm going to get ready to catch another shell. So wait, I only have one session running. I need to run that curl command. I did something wrong in the curl command. I missed one of the characters in the copy paste. So I need to do it one more time. And when I paste, I get another connection in to my Metasploit console, which is not running in the cluster. So now I've got two sessions. These two sessions are to two different pods. So I look at the second session. I run host name. If you're on host name in a Kubernetes in a container in a pod, that the host name you get will be basically the pod name. So we get Lucas Lee fan requests, and so I can go starting with making the environment a little more pretty. Oh, looks like I've hit the end of that video, and I just need to pop up the second one. So I have this all organized into playlist. So we're on Lucas Lee fan requests. We look at the flag and it says, okay, you defeated Lucas Lee. So now can you get the next Evil X, Todd Ingram? And we're going to do just one more and we're going to stop there. So it says, hey, we're Todd. So in the movie, Todd Ingram has these special Jedi powers. They're not Jedi powers, they're vegan powers. He's got like full telekinesis. He can read minds. He gets these powers because he's a vegan. And apparently, the way he says in the movie, you know how that we only use 10% of our brains? Yeah, that's because the only other 90% are filled with curds and whey. So if you eat vegan, then you get vegan powers. And so the only way to defeat this guy in the movie is to get him to lose his vegan powers by getting him to eat something that isn't vegan. So we got a cool Kubernetes trick for this. I'm really proud of this. So it says, hey, you've defeated Lucas Lee. Oh, also the other thing about this vegan is he's not very bright, and they make they make fun of that in the movie. I should also say the character who plays him has played Superman in one of the movies, and has played the Atom in the Arrowverse. So in like the Flash and Legends of Tomorrow and so on. Like I said, a ton of these people all went on to superhero movies. So Todd Ingram, it says, we're trying to get Todd Ingram to consume something that isn't vegan. So we use this URL to offer him food. So the Todd Ingram pod is offering an API called Eat, and you tell him the name of some food. And here's the problem. Todd is so dumb that he asks Roxy Richter, one of the other Evil X's, about every food we offer him. She runs a microservice called Is It Vegan? And so what we want to do is see if we can trick Todd into eating gelato, which is decidedly not vegan, and we'll get him to do it. We'll get him to do it by way of man in the middle. And when he goes, or monkey in the middle, and when he goes to ask When Todd's pod makes a request to another pod, to the Roxy Richter pod, to say, hey, is this vegan? We want the answer to not come from the real Roxy Richter pod. We want to answer that
Ah,
question. So we're going to ask him a question, and then we're going to race and send him an answer before he can get the real answer. And our answer will always be yes. So anyway, this hint says, here's how to ask him to try gelato. Here's how to ask them to try tofu. Here's how to ask them to try half and half. And we can base 64 decode these to see what they are. But we'll have to. We're going to offer them gelato. So hopefully we'll be smart enough to just, copy and paste. So let me see if I can. Okay. So I'm sorry, I jumped it a little. So what we do is first we send him a quick, like, we sent him we sent him one of these requests, like, hey, try eating gelato. And he says, I won't eat that. Okay, so he won't eat that. So now let's go and get out our kube control. And we run kube control get services. Remember, services are those internal load balancers. It's how all these things find each other. So we'll say get service, and we'll ask to see the contents of the is it vegan service, the contents, the description of it. And the service is it vegan. So it's got an IP address, it's got a virtual IP address. All traffic going to that address on port 8080 is going to get sent to port 8080, and it'll get sent to port 8080 on any of the endpoints for that service. Like endpoints, any containers that are supposed to be getting the any containers that are supposed to that are the endpoints that are supposed to be the true destinations of that service.
mm-hmm.
The thing is, in Kubernetes, everything is ephemeral. The idea is that the nodes in the cluster can fail at any time. The pods in the cluster can fail at any time. Also, outside of failure, that we're horizontally scaling all the time. So we're adding more nodes, we're adding more pods. And so what we do is, instead of giving the pods well-defined names, we usually, we're not doing this here, but we usually create deployments which are like sets of pods. And those sets of pods can like scale up and down as they need to. And so instead of saying these are all the pod endpoints and listing them and having to maintain that list, we just label the pods. The cool thing is, as an attacker, if you know what the labels are, the service is going to send things to, and you're allowed to create your own pods with their own labels, you can make your pod labels have the same labels as wherever the traffic's supposed to go to. And if you do that, then you will be getting not all the traffic that was headed coming into that service, but a lot of it. Like, we could start up, if there's one true endpoint, we add one more, we'll get 50% of the traffic. If we have enough resources, we could add 99 more, we'll get 99% of the traffic. So here's what we'll do. So we're going to create a pod. If we're allowed to stage a pod, then all we got to do is create a pod that has the same label. This label is app set to evilx4. So we'll create a pod. Its label will be app set to evilx4. Its name will be MITM for monkey in the middle. And instead of using whatever the container image that Roxy uses, we'll use one that I've created. So let's just take this and stage it. Let's see if we're allowed to. So if we're allowed to create a pod in the same namespace, since there's only one namespace here, or there's just the default namespace all this stuff is running in, then we should be able to, answer this question. So what happens now is we ask Todd the question, hey, want to eat some gelato? Todd goes and asks our service now instead of Roxy's, not our service, our pod instead of Roxy's pod, because we're both listening on the same service. Is this vegan gelato? And we told him it was, and he then gets, it's vegan, I'll eat it. No, wait, the vegan police, no. And the vegan police are actually the ones in the movie that take away his vegan powers. So that's the and he gives us, in exchange for that, we end up getting a JWT.
I was gonna say that it looks like a JOT token. Yeah, it looks like.
Yep,
yeah.
You got it. So this is a JWT for him, and then we'll be able to impersonate him. So we'll end up writing this out to a file and then going and using it to do things. Yeah. So I think I don't show you in this video the actual Yeah, I don't show you the actual the monkey in the middle pod, but the monkey in the middle pod was basically just sitting there um, answering the question in the same way that Roxy would, just with a yes or a no. But
Okay.
our man in the middle pod answers everything with yes.
Yep.
So anyway, this is just kind of a little bit of Kubernetes fun. I'm going to stop sharing my screen and I'll just talk for a second about the kind of defenses that would break this. So, um, uh, while it seems like these are just application issues, if you think about that service one, what would break it? So, in general, you've got these things called namespaces, Kubernetes, and you, when you allow a service account or a user or a group to do things, you basically usually you kind of make that rule at the namespace level. So, the issue here was I was allowed, as an attacker, I was allowed to create pods in the same namespace as well as somebody else. It was kind of like the equivalent of like Coke and Pepsi. If you can imagine those two might potentially be in, some kind of industrial espionage situation.
Right.
If Coke and Pepsi are allowed to create pods in the same namespace, then yeah, either of them can monkey in the middle traffic from each other. So first and foremost, you don't let them do that. But you can do more than that, actually. If you've heard of Istio or any of the other service meshes, um, Istio is really cool. If you add Istio to a Kubernetes cluster, one of the things it does, it basically makes it so that all the traffic going into and out of every pod in the cluster um, is going to gets a little tiny proxy program added to it, and that proxy program is how Istio basically pushes configuration of the proxy, and it also pushes a unique identity, a unique TLS key pair to each proxy. And so now every single thing talking to anything else in the cluster is able, if you use this functionality, is able to mutually authenticate, do mutual TLS. So encrypt and mutually authenticate its communications to anything else, which definitely breaks that one. Um,
Nice.
we could also be like, wait a second, you could also do some of this with network segmentation. And the cool thing with Kubernetes is your network segmentation doesn't have to be down at the level of networks like we might do in kind of I was going to say in the real world, but like in data centers, your network segmentation can be at the level of labels. Um, and so you're able to say my pod will only, pod, sorry, not my pod, but pods in this application will only accept traffic, will only accept traffic from pods that have the right set of labels. Um, and then, in terms of avoiding people getting to use whatever the hell labels they want, you could actually use there are tools like Kyverno and like OPA Gatekeeper, where you can say, I'm gonna make rules and say that you're not allowed to put a pod in my cluster that is that uses these labels unless it uses one of these images or what have you. You can even make it so that if someone's allowed to stage things in your cluster, they're only allowed to stage containers in your cluster if they're from a specific allow list of containers, so of container images. So it's kind of cool. Anyway,
Very
there's
nice.
tons more. If you want to like play with this, just go look on YouTube for Kubernetes attacks and defenses. You'll find a bunch of my talk. We also find talks from a bunch of people who are a lot smarter than me. And if you want to if you want to take a class, we do some free classes at InGuardians, and then I do private trainings and the Black Hat class. So
Very
be
cool.
happy as a
And
student.
so are you're I just to reiterate for those who may have come late, you're going to be giving which class at Black Hat this year?
Sure. So I'm going to be teaching. I teach a 4-day class at Black Hat, and it's it's on attack and defense. Let me grab a link. So wow, actually, if you look at hey, follow me on Twitter, JayBeale. As my Twitter handle, and then InGuardians is INGUARDIANS on Twitter as well. My pinned post right now on Twitter is my class, and the class is called Abusing and Protecting Kubernetes, Linux, and Containers. and I'm gonna paste that into the Twitch stream right now.
There you
Um,
go.
and yeah, this is kind of cool actually. I like this. This is neat to be like, yeah, let me just paste that into the stream.
Yep.
And
Yeah, we're you know,
yeah,
we're I so they moved it they moved DEF CON and Black Hat to August, mid-August. Did that actually make any changes for you, considering it was supposed to be like around the beginning of July? Did that make any logistical issues for you?
I thought so. Black Hat has generally been either like August 1 or August 8. Kind of like I think that's the or July 29, but it didn't move this year. RSA
Oh.
moved. RSA moved by
Oh,
months.
you're right. You're
And
right. My
that
bad. You're
was
mad. My
yeah.
bad. Yeah. Yeah. Yeah.
But
Yeah.
yeah, so I don't know. I mean, I can't go to Vegas unless it's the absolute hottest time of the year, because otherwise I'd go outside.
Yeah.
Um,
Oh, I'm also thinking of Circle City Con. It got moved from its date to like mid August as well. So it's happening. So it goes like Hacker Summer Camp, Circle City Con, and then the same weekend that I'm doing InfoSec Camp out here in Seattle is Blue Team Con. So we've got a number of things happening in August that are huge. Not my conference, but Circle City Con and Blue Team Con are happening. So, but yeah,
I didn't realize until I was preparing for this today that your conference, the InfoSec Camp Out is so close to Seattle.
yeah,
It's
Carnation about 45 minutes outside of town. Yeah.
Yeah, I mean, like literally, I Google mapped it because I know, like, someone will be like, "Oh, it's only an hour away," and then you're like, "An hour is 2 hours and 15 minutes." But literally, I Google mapped it from my home, which is in Seattle proper, straight to the campground, and it was 46 minutes total, and I was really
Yep.
excited. So
Yep.
I may have to drop in, and I may have to offer to see if I can get you to take a talk from me, and or at least come and see somebody else's stuff.
I would not hate on that. If you would love to submit to our CFP, I can to be completely transparent, I was hoping we'd have more speakers than we do right now. So if you would love to submit to our CFP, I would not hate on that. We're also looking for workshops. So if you would like to give some or some portion of your Kubernetes stuff, we're also looking for workshops that would last longer than an hour or 2 hours. So
Nice.
go in Guardians is right there. Yeah, we're not tour camp. So Jay, I don't know if you've ever been to tour camp, but we're not tour camp. Our little under thing says, InfoSec Camp Out. If it sucks, at least you can drive home. That's our tagline. So
Is it really?
no,
That's
I'm just
amazing.
kidding. Matt Domko, our VP, he was like, yeah, we should have something like that. And I'm like, no, that automatically assumes that it's going to suck. So, but yeah, we're not tour camp. So we're not trying to be tour camp. Ours is very much a backyard style camping excursion kind of thing. But last year we did have the tour camp people show up because theirs got canceled. So we did have some good times with them last year. I would definitely suggest if you ever wanted to get involved with the tour camp experience to go do that as well. And theirs is in July, I think. So I don't know if there's still some tickets left for them, but if you can't get any for tour camp and you still want to do the somewhat camping experience, come and hang out at ours. We're like half a mile from a Starbucks. I mean, we're not even roughing it. So at this point, there's
Yeah.
a supermarket and a Starbucks in Carnation. So, I mean, but yeah, I would love for you to come by and, we'll get you the CFP link for the talk and everything. Yeah.
Yeah, you gotta put the CFP in here too in the Twitch stream.
Yes. So for everybody, infosecampout.com. I'm going to fix the website link. It is just a GitHub page. We are very much low budget. We're like Wayne's World,
Nice.
public access TV or what have you. We do have our social contract on there. We have links to various things. The CFP submission link is there. So if anybody's interested in, it's a Google form. So yeah.
Nice.
Wendy is who is one of the organizers of B-Sides Las Vegas, set that up for us. She's also one of our officers. So, but yeah, so we have some additional viewers here. Bloodborne asked the question about this was a hybrid method, hybrid spoof. Bloodbound, could you maybe expound upon the hybrid spoof comment you made if you're still here? And if anybody else has any other questions about, Kubernetes or, in Guardians or, just, pen testing or security assessment in general, we got about another, I'd say 5-6 minutes here. And then I'm going to let Jay go. And cause he's, CEO and CTO and marketing person. And I'm sure I'm sure his partner would love to have him come join them for dinner. So yeah.
Definitely.
Yeah.
So I gotta go down and cook dinner.
Really? What are you making?
Yeah, dinner's I don't know. So she tells me what to cook. And she guides me, and I really appreciate it because I by the time I get to the end of my day, I'm not thinking quite as much. So it's nice. So she makes me lunch, I make her dinner, and
that's very cool.
Yeah. So
one of the things that during the pandemic really revolutionized our cooking was sous vide water bath.
Oh man,
yeah,
I've heard about it. I've
really upped the steak game. And they're it's fairly cheap. So we have a 12-quart like stock pot, and we just have a sous vide, and we just drop our steak in there and let it go for about 4 or 5 hours. Put it on the grill, kiss, done. That kind of thing. It's really great. It's really
so
great.
Mike Poor here made for a bunch of us. We had like we had a big like got an Airbnb and had a bunch of people in a meeting out here in Seattle a number of years ago, and he brought like a sous vide setup and yeah, sous vide. I really need to start doing it. At the time, I was a little turned off by the plastic. But one of the things that he's told me is that like really often if you're having a steak in a restaurant, like they made it with sous vide because that let them get that let them get a kind of consistency that is just so much easier to get with sous vide.
Yep. So yeah, and they can prep things way in advance. Vegetables, sauces. You can make a béarnaise. You can poach eggs. I mean, you can do other stuff other than just do meats. But yeah, I mean, it's really a great time saver. I can put steak in, or I can put in some carne asada or something at lunch, and by 4 or 5 o'clock we're ready to eat, and all we have to do is just slap it on the grill for a few minutes. And doesn't matter what time of year grilling. We grill all times of year up here in Snoqualmie. So
I'm starting to wonder if this is a thing for Burning Man. Like, because like a lot of my friends when I went to Burning Man, I had I didn't eat that well, but a lot of my friends would basically order food from their favorite delivery restaurants and without air, but so sous vide without air, but they were vacuum sealing cooked food,
right.
And they get there and it's like ready to go. But I love the idea of
upscaled leftovers. Yeah.
Cool. So
very nice. Okay, well, I think we're gonna go. Hope everyone was hanging out. I want to see if we can raid somebody if we can, because we have a number of watchers here. Just see who's available. Let's see who's on here. But yeah, Jay, appreciate you coming on. I've known Jay for a few years, even before I started doing the podcast. I'd seen him on seen him at conferences and all that. Wow, we don't have anybody on from security wise. That's unfortunate. Oh well. Wow. Well, they're lost. Would love to see you come out to InfoSec Camp Out if you can. There's no pressure, but I mean we're outside. We're not doing anything that's not indoors, which is one reason I'm like, yeah, we can probably still somewhat safely continue to do our conference instead of being inside.
I gotta see if I can get a few people from InGuardians, who aren't yet ready for, for an in-person conference.
Right.
I like you kind of getting me pretty excited by the idea of like wow, pretty close to home, and and I
Yeah.
don't have to think about the COVID so much,
Yep.
and um, and camp out, and
We have
yeah, that
power. It's
sounds.
like RV hookups and stuff. So if y'all want to rent an RV, we've got more than enough
I
RVs. I Tesla
totally want
camped
to.
last year. So I have a Tesla. I camped in my Tesla. So, and I'm not the only
I
one.
I have to ask you about that. The Tesla, you have a Tesla 3, and it seemed, and they say this is that was the smaller of the Tesla sedans, but like when I've only been in the Tesla 3 a few times, but yours
Oh
was one
yeah.
of them, and they're roomy as hell.
Oh yeah.
Like,
Oh yeah.
so you could sleep in it?
I have. I
How do
wished I
you,
had a
what do you
better air
do?
mattress, but because I'm kind of a bony ass now that I've lost 60 pounds, I don't have as much fluff. But oh, Tiberius. Okay, we'll raid some
I
Tiberius
knew
here in a
you looked
second.
different. When did you lose all that weight?
It was I would say just a little bit before the pandemic, around 2019. But I've kept the keto lifestyle between in the pandemic, and I have I'm a bit of a home gym rat, so I've got my so I have 60 pounds of dial in weight here, and you know,
Hold on a second. Let's see.
I can
I'll
only do
get a.
160. But yeah, this is 60. It goes up to 90. These are the power blocks. Oh yeah, look at you. We're
Yeah,
dial
this
in
is
weight
the.
buddies.
Yeah, we're dialing weight buddies.
Yeah,
So
I have the power block ones that go up to 90 pounds. But yeah,
yeah. So I thought about the power block because they're expandable up to that. That's like,
yep,
but this was at a point of the pandemic when it was like you could wait 1 month
yeah,
for the ones I got, or 3 months for the power blocks, because all gym equipment was
yep,
out. So
yep.
took
Yeah,
me forever before I convinced myself to spend, a couple $100 or $300 for dumbbells.
I've got
But it was
dumbbells. I
well
also
worth it.
have elastic bands, 300 pounds of those. And
Nice.
it's just a nice way of doing so. And then I have a weight vest that goes up to 60 pounds that I ruck with. So right now I'm at like 42, but I can do 2.5 miles of rucking in up and down hills with my stuff. So, but yeah, it's
I
just
got a weight vest for my Oculus Quest. So
oh,
mine also goes up at around 60 pounds or so.
very
And
nice,
so I'll put it on, and then I'll do an Oculus Quest game. The only video game systems I've had since college
nice.
are the Oculus, which can be very physical, and the Xbox
Yep,
360 with the Kinect sensor, which
yeah,
again, very
very nice.
physical. And yeah, I
Yeah,
got the yeah. No, we all got. I think so many of us got home gym setups. Like got more and more stuff in our home gym.
yep,
Like all of a sudden, it's
yep.
like, well, I can't. That gym membership money's not going to go to a gym anymore. So I guess I can. I guess I can and have to put something in the house.
Yeah,
So,
not for the near future, and we're not all Dave Kennedys. So that Dave boy, he's on a completely different level. I don't know.
oh my God, he totally is.
Yeah, yeah,
It's very,
yeah.
yeah. He is certainly crushing it. I did end up getting on his Whoop band community.
Okay.
Um, yeah,
Yeah.
and that made me lose weight, and I've never thought I was
Okay.
going to try to lose any weight. I didn't mean to lose weight. It was just all of a sudden my activity level got so high,
Yeah.
that like I started losing weight and needed to figure out how to put it back on.
Oh
Um,
wow.
but but
Yeah.
yeah, it's a um, but yeah, no, it's. I mean, the pandemic I think was hard on everybody. We all, most of us started like I think almost everybody started eating a lot more,
Yeah.
and so that after a little bit you're like, okay, well, how am I going to counter for that too? So
Yeah.
um,
I've always had issues with portion control, and what happened was in 2018 I actually slipped and fell on the deck and messed up my knee, and I was unable to do a lot of stuff. And then I realized, well, I'm not young anymore. So I need to do something. And I realized that, I was like 247 pounds, 245 pounds. And I was like, I got to do something different because, busted my ass. And if, it's a knee today, it could be a hip tomorrow.
yeah,
So it took about 3, 4 months for that knee to stop aching. I
Yeah.
probably tore something in there and it just took a while for it to, fix. But yeah, after that, I was like, I need to do something different. And so I did, keto, intermittent fasting. And then the pandemic happened. And I was like, shit, I'm going to need something because I was going to the gym, 3 days a week. So picked up my home gym and I don't see any need to go back yet. But yeah,
Mm.
it's definitely been a game changer for me. Had somebody
You
else
look really
mention that
healthy,
too.
man.
Yeah, I appreciate that. You look great too. You
Mm.
fantastic.
Trying.
Um, yeah, but yeah. So thank you, Jay. Yeah, like I said, I hope we'll be able to see one another very soon. And yeah,
Me
let
too.
the Guardians folks know we're looking for speakers. I would also suggest any of our people in our chat here, if they work for large organizations with security teams, or want to come and hang out outdoors. Suck. Fall off the keto wagon, have a s'mores or something. You can
Sounds good
definitely,
to
hey,
me.
Wicked, what's up? And yeah, we can, have some good, well mannered frivolities. So, all right. So
Everything in
Jay, thank
moderation
you.
sounds good to me.
Yeah, go make some dinner, and yeah, we'll talk soon.
Awesome. Talk to you
Cool.
soon.
All right, thanks,
Bye.
Jay. All right. Thanks everyone for coming, and hope everyone learned something on Kubernetes. I do apologize for the first 20-25 minutes where we had OBS CanX on us for a few seconds. I don't know why it was crashing. The only thing I could think of is I had too many things open. I don't know. But anyway, so stick around. I'm going to try to raid Tiberius, see if he's available. And we're going to raid Tiberius in 8 seconds. 7, 6, 5. Thank you all again for coming. And you can check the VOD out with Jay and talk and learn about Busted Cube and Guardians and everything. Bye.